A very good morning to one and all. I'm Priyanka Sapkal from Goregaon MPS Municipal Secondary School East. So students, today we are going to continue with our topic of chemical reactions and equations. Okay. Yesterday, students, we studied about the 4 types of reactions. First one was the combination reaction. Second one was the decomposition reaction. Third one was the displacement. And in displacement, we studied single displacement reaction and double displacement reaction. And so today we are going to study about the oxidation and reduction reaction. But before that, just we will recall few of the points, and with the help of these examples, we will see which type of reaction is this. Now, just see the first reaction, MgCl2 plus twice KOH. Okay. So here in this case, we are getting the product of MgOH by 2 and KCl. So here manganese chloride, okay, magnesium chloride, sorry, and potassium hydroxide. We will get magnesium hydroxide and potassium chloride. Now here in this case, what happens? Just if in the exam it is asked, just tell us what type of reaction is this. Then go through the list of the types of the reaction. So first was the combination reaction. So according to our rule, for the combination reaction, what must be there? There should be 2 reactant and 1 product. So this first reaction does not satisfy that. So hence it is not a combination reaction. Then our second type was decomposition reaction, where 1 reactant is there and it breaks down into products, 2 or more products. So here on the reactant sides, there are 2 reactants. So hence it is also not satisfying the properties of the decomposition reaction. Then comes the single displacement reaction, where replacement will take place. Now here in that also single displacement reaction. Now according to the rule of the single displacement reaction, there should be 1 element and 1 compound. But here in the reactant side, there are 2 compounds. So hence it is not satisfying the properties of the single displacement reaction. Then comes towards the double displacement. Now in the double displacement, 2 compounds react with each other. Now you can see in the first reaction, 2 compounds are there. So hence we can say that this might be double displacement reaction. But the confirmation comes when you see the product. So in the product side, you can see that the replacement of the what? Mg and K happens here. Now Mg and potassium, that means Mg and K, these both are the metals. And chlorine and hydroxide group, these both are the non-metals. So either the exchange of the metals will take place, or the positive element will take exchange of the non-metal will take place. So here in this case, if you can talk about that, here exchange of the non-metal have been taken place, as you can see here. So here that's why we can say here, now in short we can say that here displacement of the 2 non-metal elements have been taken place. So hence it is a double displacement reaction. Second one also the same case, NOS, that is hydrochloric acid, and of course here sodium hydroxide. Now what happens here? Here again exchange of metals or non-metals will take place, and hence we will get the product. So here 2 elements, they will replace themselves, or they will displace themselves. But before displacing, what they will do first, they will gets converted into the ions, and after as they get converted into the ions, the positive and the negative charges will combine, and hence they will form a new compound in the product side. So here exchanges of the elements takes place. So here also we can say, so here both the examples are the examples of a double displacement reaction. So likewise you have to go through the reactions, that will be easier for you. Just go through this short and simple rules of how to understand which reaction is there in that particular given chemical reaction. Okay. So now it comes towards the next reaction of redox reaction. But for redox reaction, we should know what do you mean by the oxidation and reduction. Because in redox reaction, what happens? Both the oxidation and the reduction takes place. So as both the oxidation and reduction takes place, so here it is necessary to study both of them. So first we will go towards the oxidation. So before studying the oxidation reaction, the word oxidation means what? Okay. Now oxidation is the loss of electrons during a chemical reaction by a molecule, atom or ion. Now here in this case, oxy, the name itself tells us oxy means addition of oxygen. And when the addition of oxygen takes place, naturally there will be the loss of electrons. This point that oxidation, oxy means addition of oxygen, and hence whenever the oxygen added, in that case loss of electrons will always take place. Okay, so here oxidation is the loss of electrons, and hence during a reaction by a molecule, atom or ion. So oxidation occurs when the oxidation state of a molecule, atom or ion is increased. Okay, so here it occurs whenever there the oxidation state. Now here in this case oxidation state, you can say that, for example, sodium is there. Okay, sodium element is there. As we know that the atomic number of sodium is 11, and hence what it will do, one in the last subshell, one electron is there. So what it will do, it will donate its electron. Now when it will donate its electron, it will donate only one electron, because after donating one electron, sodium will get it will have that outermost shell, only one electron is present. So if it will donate the electron, then it will gain the, it will complete its octet. So for that, what it will do, it will donate, and after donation, what happens, whatever the number of electron it will donate, it will get a positive charge. So that positive charge indicates the oxidation state of a molecule. Okay, so here in this case, so we can say that gain some positive charges. So hence oxidation state of metals, you can say it is more, because it loses the electrons. So our property for the oxidation is that it loses electron and addition of oxygen takes place. Then comes the reduction. The reduction is totally opposite of it. So the opposite process is called as reduction, which occurs when there is a gain of electrons, or the oxidation state of an atom, ion or molecule, it decreases. Now here in reduction, what happens? Gain of electrons takes place. See here, whatever the points are there for the oxidation, the totally opposite point will be there for the reduction. So here in this case, what happens? You can say that here in the reduction, there is a gain of electrons. Okay, so here loss of oxygen and gain of electrons, you can also say like that. Okay, so here gain of electrons takes place, that's why it is known as the reduction. So in this state, what happens then, as it is the gain of electrons, so here in this case we can say that the loss of electron will be not there. Here gain of electron will be there, so the oxidation state will naturally, it will decrease. Okay, here you can see the reduction. So reduction is a chemical reaction that involves the gaining of electron by one of the atoms involved in the reaction. Okay, it is gaining of electron by any one of the atom which is involved in the reaction given to you. In that, or two elements are given to you, in that one will reduce, another will oxidize, or you can say that one can be reduced by gaining of electrons. So the term refers to the element that accepts the electrons. So as the oxidation state of the element that gains electron is low, so in that case what happens, whatever the oxidation state will be there, it goes on decreasing. Why? Because as it is gaining the electrons, if it start losing, then the oxidation state will increase. But if it is started gaining the electrons, then in that case oxidation state will be lower. Then an example of a reduction is when iron reacts with oxygen. Now as you can see that whenever any iron compound is there, any iron tool is there, okay, after some time it goes on rusting. Okay, rust appears there. Why the rust appears? Because it reacts with the oxygen. So what happens when it reacts with the oxygen? It forms the iron oxide. When it reacts with oxygen, it forms the iron oxide. So that particular thing is known as the rust. So the iron is oxidized and the oxygen is reduced. Now in that case, what happens when iron reacts with oxygen? Iron, it gets oxidized. Oxidized means what? What happens there? It loses the electrons and it gains the oxygen. Okay. And what oxygen does, as the iron loses electron, the oxygen gain those electron. Now in a chemical reaction, one element or one compound will either lose electron and the another element will gain that electron. Okay, so here in this case same happens. Iron, what it will do, it will oxidize, it will lose electrons, and the oxygen, it will gain electrons. That's why oxygen is reduced here. Now in this case, what happens, that process of rusting is having the redox reaction, because here in this case both the oxidation and reduction takes place. Okay, so here in this case iron is oxidized and the oxygen is reduced. That means iron is losing its electron, that's why it is oxidized, and the oxygen is gaining that electron from the iron and hence it is reduced. So in short, you can say that oxidation is nothing but the loss of electron and reduction is nothing but the gain of electron. Okay, so one of the best example is any of the substance you tools are there and utensils, whatever you have, you can see that those tools or those materials after some time it gets rusted. Why the rusting process happens? Because it reacts with oxygen and it forms the iron oxide. And that's why, that means here in this case, what happens? Redox reaction takes place. Then one of the example is a blast furnace reverses that reaction using the carbon monoxide as a reducing agent to reduce the iron. Okay, so this is the reverse process. Okay, so one of the example we will see. Now, here in this example, you can see both the reduction and the oxidation takes place. Now, how it happens? CuO, that is the copper oxide, when reacts with hydrogen. As I already told you before, H2, O2, N2, okay, Cl2. So these are all those elements which does not appear in a free state. They will appear in a combined state. That means hydrogen, either it will be having another element or it will react with itself and form H2. Okay, it will never react alone, that is H. Likewise, like that, it will never react. Okay, because they are always present in a combined state. Now here H2 is present. Now CuO, that is copper oxide, when reacts with hydrogen, what happens here? Now you can see that copper oxide, oxygen is present in that. Okay, so as oxygen is present, so what copper will do? It will loses its oxygen. Okay, it will lose its oxygen, and what happens then? This oxygen is gained by the hydrogen. Now always remember, for the reduction process, few of the properties of the reduction is, first of all, the gaining of electron is the process of reduction. Then the oxygen, whatever the oxygen is there, when it removes the oxygen, that is also one of the properties of the reduction. Okay, so the property of reduction is loss of oxygen and gain of electron. So here in this CuO case, what is happening? Oxygen is loosened by the CuO and it is gained by the hydrogen. So here in the product side, you can see that Cu will be formed alone and H2O will form, that is water molecule will form. And how this water molecule is formed? Because hydrogen gained that oxygen. So whenever any element gain the oxygen, in that case we can say it is an oxidation process. Now the properties of oxidation is gaining of oxygen and loss of electron. So these are the reverse process. Gaining, if any element or if any compound, if it is gaining the oxygen, then it will naturally lose the electron. If any element is losing the oxygen, then it will gain the electrons. So here in this case, you can see that CuO is there, so it is the oxygen is loosened up by it, and hence it is gained by the hydrogen. So in this case, in the product side, copper is reduced, and the hydrogen in the product side, it is oxidized. So here addition of oxygen is oxidation and removal of oxygen is reduction. Now here in this case, we can say that if in the reaction this process also happens, either the removal of oxygen or addition of oxygen, then that process also is a reduction and oxidation process. Now whenever in a reaction, when these two processes occur simultaneously, that means one compound it is losing the oxygen and another compound is gaining that oxygen. That means in a one chemical reaction, only these two processes are happening. Then that process is known as the redox reaction. Okay, just see towards the below chemical reaction, removal of, here in this case Fe3O4, and here H2 is there. Now what happens here, also the same case happening, removal of oxygen takes place from the compound of iron, and here in the product side we are getting the iron alone. Okay, whereas the that means hydrogen is gaining the oxygen, that's why water molecule is formed. Now here in this case, which compound is reduced? Here in this case, element of iron is reduced. How it is reduced? Because it removes the oxygen. So whenever removal of oxygen is there, that means it is a reduction process. And whenever addition of oxygen is there in whatever the elements, in that case, we can say it is an oxidation process. So here in this case also, reduction of iron takes place and oxidation of hydrogen takes place. So here in this case, both the reduction and oxidation is taking place, hence it is a redox reaction. So now we will see the difference between the oxidation and reduction, because most of you get confused with this oxidation process and reduction process. So oxidation means what? Oxy means whenever the word oxy comes, that means here gain of oxygen is there. Oxygen is added here. If oxy word is there, that means oxygen is added. But whenever reduction is there, that means loss of oxygen. It means whatever the points will be for the oxidation, the totally reverse point will be for the reduction. So if you know the points of oxidation, then you can easily assume the point for the reduction process. Then the second one is for in the oxidation, loss of hydrogen takes place. Why the loss of hydrogen takes place? Because oxygen, we are gaining the oxygen. So naturally, if you are gaining the oxygen, there will be loss of hydrogen. So if loss of hydrogen is there in oxidation, then in the reduction, there will be gain of hydrogen. That means if in any chemical reaction, what happens? Now see here, in this reaction, what we saw is there is a removal of oxygen and addition of oxygen. Okay, but suppose if any chemical reaction is there where addition of hydrogen and removal of hydrogen is present, in that case also you can refer that particular reaction as a reduction and oxidation reaction. Okay, so here what we can say that if there is a loss of hydrogen, then naturally it is an oxidation process, and if there is a gain of hydrogen, then it will be a reduction process. Then oxidation also means that the loss of electrons. Okay, so if loss of hydrogen is there, so naturally there will be loss of electrons. Then in the reduction, if gain of hydrogen is there, so naturally there will be gain of electrons. That means here in this case, if any chemical reaction, if there is a loss of electron, that means if you are gaining a positive charge in one element and you are gaining negative charges in another element, then what happens? What you can say that there the process of oxidation and reduction taken place. Okay, so here in that case also we can assume the reaction as oxidation and reduction reaction. Then comes increase in oxidation number. As I already told you the example of sodium, what happens then as it loses electrons, it will gain one positive charge. So hence few of the elements are there, when they lose electron, they gain and charges, positive charges. So that means here increase in number of oxidation number, it increases, okay, as you lose the electrons. But whereas in the reduction process, what happens as there are gain of electrons, so naturally if gain of electrons means no loss of electron, and if no loss of electron, that means positive charges will not be there or it will go on decreasing. So hence decrease in the oxidation number. Okay. So if in any chemical reaction, if one of the process from these points will happen, then that particular reaction will be a oxidation reaction or the reduction, or it can be both oxidation and reduction process. Okay. So once again, we will revise. In an oxidation reaction, what happens? Oxy means gain of electrons, and in reduction, there will be loss of oxygen. Okay, sorry. Oxidation means gain of oxygen, and in reduction, there will be loss of oxygen. Okay. Oxygen and reduction, loss of oxygen. So just keep in mind these things. Then afterwards, oxidation means loss of hydrogen, as hydrogen will be lost and oxygen will be gained. Okay. And if hydrogen will be lost, that means loss of electron is also there for the oxidation process. Whereas for the reduction process, if oxygen will be lost, then naturally electrons will be gained and hydrogen will also be gained. Okay. Then for the oxidation process, there will be increase in oxidation number, whereas in reduction process, there will be decrease in oxidation number. Okay. Next, you can see here one of the example. Now here we have taken elements Cu and Mg. Now here in this case, Cu is having two positive charges. Okay. And Mg is neutral here because it is not showing any of the charges. Now here Cu die positive. What it will do? Okay. Now here in this case, it will gain the electrons. Gain electrons from where? Gain electrons from the Mg. Now Mg is neutral here. So what it will do? It will oxidize. Oxidize means it will lose its electron, and it will, after losing the electron, what it will do? It will give its electron to the Cu after losing. So whatever the electrons are lost by Mg is gained by the Cu, and hence removed from the Cu because it gains electron from Mg. Two electrons it gains from the Mg. That's why it becomes now neutral, and Mg will get two positive charges. Okay. So here you can see two positive charges shows that there is a loss of two electrons. Okay. There is a loss of two electrons. That's why two positive charges are showing over Mg. So here that means whenever like this loss of electrons takes place. Okay. So the Mg, it loses the electrons. That's why it is oxidized. And Cu, it gains the electrons. That's why it is reduced. So here in this case also, in this reaction, both the oxidation and reduction process is happening. Okay. So up till now, we studied about the oxidation and reduction processes. Now we will study about the oxidizing agents and reducing agents. Now, most of the time you get confused with the oxidation and oxidizing agent, reduction and reducing agents. Okay, because you feel that these are all the same terms, but these are not the same terms. Okay, now see the word oxidizing agents. Okay, now what is the role of agent? Okay, when you're talking about the agent, what is the role of agent is just it get the work done of the another person, but himself he is not doing. That means he is not doing his work, he is doing the work of another person. Okay, that means here the oxidizing agents means what? It is an agent, it is itself not going oxidation. Okay, but it makes the oxidation of the another compound or another element. That's why it is an oxidizing agent. It does the oxidation of another compound or another element. Same way for the reducing agent, it reduces the another element or another compound, but itself will not undergo any reduction. Okay, itself it will not undergo reduction. It will make the reduction of another element or another compound. That's why it is known as the reducing agent. Okay. So here below it is given oxidizing agent and reducing agent. Oxidizing agent means what? It itself will reduce. It will itself reduce, but it will make the oxidation of another element or another compound. Whereas reducing agent means what? It itself will oxidize, but it will make the reduction of another element or it will make the reduction of another element or another compound. Okay. Then oxidizing agent also gains the electron because as it is itself getting reduced. So that's why it will naturally gain electrons because this is the property of reduction. Whereas in reducing agent, it itself undergoes oxidation and hence it will lose electrons. Now you might have seen that while just booking the tickets, what you do sometimes, you tell to the agent to book the ticket. In that time, what the agent will do, he will not book his own ticket. He will book your ticket only. So same way, oxidizing agent means what? It will itself not undergo oxidation. Okay. But it will make the oxidation of the another element or compound which is present in the chemical reaction. But it will itself undergo reduction. Okay. So here reducing agent and oxidizing agent is given. The substance reduced is the oxidizing agent and the substance which is oxidized is the reducing agent. So here the agents, oxidizing agent and reducing agents are totally reversed from their work. Okay. Oxidizing agent is doing itself reduction and reducing agent it is itself undergoing oxidation. For example, sodium is there. Sodium loses one of the electrons, and after losing the electron, what happens? It will gain one positive charge. Okay, after losing the electron, it will gain one positive charge here, as you can see in the product side. Same way, sodium is also here in this case it gets oxidized. Why? It is getting oxidized because it is losing the electron. And what is the property of oxidation? That whenever any element it loses the electron, then it is undergoing oxidation. Is oxidized. Now it is the reducing agent. So as it is itself undergoing oxidation, so hence it is a reducing agent. Now what will happen? The electron which is lost by the sodium will be gained by the chlorine. Okay, it will be gained by the chlorine, and what will happen? Chlorine will gain it. So as chlorine is reduced here, chlorine is reduced because it is gaining the electron, and as itself it is going reduced, so that means it is an oxidizing agent. That means chlorine oxidizes the sodium, then because of which sodium loses the electron, and the electron which is loosened up by the sodium, it is gained by the chlorine. That's why chlorine get reduced. So we can say that chlorine is an oxidizing agent and sodium is a reducing agent. Okay. So here, wherever both these reactions happen at the same chemical reaction, then we called it as a redox reaction. So here in this case, X will give it will, what does this mean? Now oxidation is loss of electrons. Okay, oxidation is loss of electrons. So oil, here OIL is given. O stands for oxidation, I stand for ease, and L stands for loss of electrons. And RIG, it stands for the reduction is gain of electrons. Okay, so here in oxidation, loss of electron will take place. That's why what X is doing, X is losing its electron. That's why in the arrow electron is shown, and here after electron is shown as. So here in this case, what is happening? S is losing the electron, and hence we will get one product. Okay, and that product will gain the electron. So X, as it is losing the electron, so it undergoes oxidation, and Y, it is gaining the electrons, and hence we can say that it is undergoing reduction. Okay, so here in this case we can say that here both the oxidation and reduction is taking place. Now X is oxidized by Y. Why X loosen the electron? Because Y oxidizes the X. Okay, so hence as Y oxidizes the X, that means we can say that Y is an oxidizing agent. Okay, and X is a reducing agent because it gives its electron to the Y. That's why we can say that X is an reducing agent. Okay, so here in this case, Y is an oxidizing agent because it gains the electron from the X. That means it makes the X to lose its electrons, and X is a reducing agent. Why? Because it loses its electron, okay, and makes the reduction of the Y. So X increases in oxidation number and Y decreases in the oxidation number. Okay, so why X increases in oxidation number? Because it is losing the electrons. And why Y decreases in oxidation number? Because it is gaining the electrons. So here, this is the redox reaction. Again, the same example, CuO and H2. So what we will get? Now CuO, it loses the electron. After losing the electron, according to a property of oxidation and reduction, whenever any compound is losing its that means it is losing the oxygen. Here CuO is losing the oxygen, then that means it is oxidized. Okay, sorry, it is reduced because it is losing the oxygen. So that's why Cu will be reduced. But that oxygen will be gained by the hydrogen. And if the oxygen is gained by any compound or element, then we can say that that particular compound and element is oxidized. So here CuO will reduce to Cu and H2 will oxidize to H2O. Now here in this case, as CuO is reduced because it is helping H2 to gain the oxygen. That's why it is an oxidizing agent. And why H2 is reducing agent? Because it is gaining the oxygen, and hence as it is gaining the oxygen, that means it is itself undergoing oxidation. So that's why it is a reducing agent. Here one of the example is given, Zn plus Cu dye positive. What we will get there? Zn dye positive and C. Now zinc, what it will do? It will lose. Okay, it will lose its 2 electrons. Okay, so that means it is itself undergoing oxidation. Okay, and zinc will reduce 2 electrons because in the product side you can see whenever any element is losing its electron. So here you can see that 2 positive is gained by the 2 positive charges are gained by the zinc here in the product side. Why? Because it loses 2 electrons. Okay, and as it loses 2 electrons, that means it undergoes oxidation. Then these 2 electrons are gained by the Cu dye positive, and hence it gets, what happens? It gets reduced to Cu. So that means here reduction of copper takes place and oxidation of zinc takes place. Okay, so here in this case, as zinc is making the reduction, or it is making the reduction of copper. So in this case we can say that it is itself undergoing oxidation and making the reduction of the another element. So it is a reducing agent. Why it is a reducing agent? Because it is reducing Cu. And why Cu dye positive is an oxidizing agent? Because it is oxidizing zinc. That's why it is an oxidizing agent, because it is itself undergoing reduction, but it is making the oxidation of zinc. That's why Cu is an oxidizing agent. Here also one example, Cu dye positive will get converted into Mg dye positive. So now what happens here? Mg, so hence we will get Cu plus Mg dye positive. Here both the oxidation by the loss of electron and reduction by the gain of electron takes place. So hence it is also redox reaction. Same way, this is also one of the example, Fe2O3 and TriCO. Now what happens here? This Fe will lose oxygen, and this oxygen is gained by the Co. So as it is losing the oxygen, so Fe will get reduced, because according to our property, whenever any compound or element it is losing, or it lose its oxygen, then in that case it is getting reduced. But whenever any compound or element it is gaining the oxygen, in that case we can say the oxidation of that particular compound or element has been taken place. So here it is also the example of redox reaction where both the reduction and oxidation takes place. Okay, practical or everyday examples of redox reactions are corrosion of iron, which we had already seen, because iron it reacts with oxygen, and in that case rusting takes place or rust formation takes place. Then when forest fire happens, then charcoal grill is also one of the example. Then natural gas burning is also one of the example. Then batteries are there. After few days you can see there are also few of the rusting type appears. Then metabolic processes, these are all the examples of the redox reaction. That means here both the reduction and the oxidation takes place. Then comes the exothermic and the endothermic reaction. Now, heat is absorbed and given away in various processes and reactions. So, accordingly, the processes and reactions, they are classified as endothermic or exothermic reaction. Okay. So, here you can see that exo means what? It is releasing the heat. So, here a reaction that releases energy from the system in the form of heat is known as the exothermic reaction. And what do you mean by endothermic reaction? A reaction that the system absorbs energy from its surrounding in the form of heat. It is known as the endothermic reaction. Now, exo means just exit. That means the energy is leaving that particular system. Whereas endo means entrance, means it is entering, it is absorbed. So hence the energy is absorbed in that case towards the system. That means the system is absorbing the energy in the form of heat. For the endothermic, endo means inside and therm means heat, we can say. Okay, heat energy. And exo means exit, it is releasing out from the system. And thermic means it is the heat. Okay, so that means heat energy is it is releasing from the exothermic reaction, and in the endothermic reaction heat energy is absorbed by the system. The example is exothermic process and endothermic process. So making of ice cubes is an exothermic process, whereas endothermic process is melting of ice cubes. In this case, what happens in the making of ice cubes? The heat energy is released, and hence this whatever the water is present, it gets compactly arranged with each other. They form a strong bond between them, and hence the heat energy is released, and hence we will get the ice cubes there. Whereas in the melting, what happens when you put out that ice tray from the freezer? What happens? Melting starts, and melting starts means what happens there? Breaking of the bonds takes place. There will be breaking of the bonds. Breaking of the cubes is an example of an endothermic reaction. That means it is gaining the heat energy. That's why it is melted. Okay. Then formation of snow in the cloud, it is also thermic process. Whereas in endothermic process, conversion of frost to water vapor. This is an example of an endothermic process. Then condensation of rain from water vapor is an exothermic process, whereas endothermic process is evaporation of water. Okay, whatever the evaporation of water is, these are all the examples of endothermic processes. Why the water is evaporated? As you know, it absorbs the heat energy, and hence because of this, it is evaporating. Then a candle flame, it is also an example of exothermic. Okay. Then endothermic is forming a cation from an atom in the gas phase. Then in the exothermic reaction, you can say that mixing sodium sulfite and bleach. Okay. In endothermic, baking the bread is an also example of endothermic process. Then exothermic is an rusting iron. Then burning of sugar. These are all the examples of exothermic processes. Whereas in endothermic process, cooking and synthesis is an endothermic process. Okay, so when you cook egg, naturally it will absorb the heat energy, and in the process of photosynthesis, what happens? Light is taken up by light water and carbon dioxide, and it makes the glucose or food, that is producing sugar by the process of the photosynthesis. Okay, that means it is gaining the heat energy. So that's why it is an endothermic process. Okay, so this is the example when twice NaHCO3. Okay, and here if it gains some energy, 129 kilojoule of energy, then what happens? It will break down into Na2CO3 plus H2O plus CO2, and hence what happens? It gains the heat energy. That's why it is in the reactant side, the energy is written here because it is gaining the energy. That's why it is an endothermic reaction. But whenever in the product side, the amount is given of the heat energy, that means it is releasing the heat, and hence it is an exothermic reaction. So here in the below reaction, you can see in the product side, it is written how much amount of heat is released. So whenever in the product side, the number of energies, the count of the energy is given to you, that means which is released in the product side. So in the product side, if it is given, then that means that much amount of heat is released. So heat exothermic process. So whenever in the reactant side it is given, then that means it is gaining the energy, it is absorbing the energy, hence it is an endothermic process. Okay. So I hope you understood this topic. So let's evaluate and let's discuss few of the questions. So what is an oxidation reaction? So for the oxidation reaction, you can definitely see this. Oxidation is what? It is the loss of electron during a reaction by a molecule, atom or ion. So oxidation occurs when the oxidation state of a molecule, atom or ion is increased. Then comes the next question. The next question is, what is a reduction reaction? So reduction reaction is totally opposite of it. Reduction means where the loss of oxygen will take place and gaining of electrons and gain of hydrogen will take place. And here in this case, oxidation state will decrease of that particular element and compound. Then what do you mean by the redox reaction? Redox reaction is nothing but the reaction where both the oxidation and reduction will take place. So that reaction will be called as a redox reaction. Then what do you mean by the exothermic reaction? Exothermic, which we had already seen just now. Exothermic reaction is a reaction that releases energy from the system in the form of a heat. Then next is, what do you mean by endothermic reaction? Endothermic reaction is the reaction that the system absorbs energy from its surrounding in the form of heat. So you can give the examples. You can give this reaction as an example for an endothermic and exothermic reaction. And in the same way, you can give few of the examples of the exothermic processes and endothermic processes, which is happening to our day-to-day life. So I hope you understood the topic. If you have any query, then just please ask. Just raise your hands if you have any query. Yes, Disha, unmute yourself. Disha, unmute yourself. Disha, Aditya, unmute. Yes, ask your question, Disha.
Hello, good morning, teacher.
Okay, yes, good morning.
Ma'am, will you please explain what is the redox reaction?
Redox reaction. Okay.
Yes, teacher.
See here. Now here we will take one simple example so that will be easier for you. Okay. First, just see the difference between the oxidation and reduction. Gain of oxygen is oxidation. Reduction is the loss of oxygen. Loss of hydrogen is oxidation and gain of hydrogen is reduction. Loss of electron and increase in oxidation number is the oxidation, and reduction is gain of electron and decrease in oxidation number. Now, if we will go through this example, You can see the first example, CuO plus H2. Now what happens here? CuO will lose oxygen. Okay, so here in this case, as CuO is losing the oxygen, that means it is what it is doing, it is getting reduced. Okay, because loss of oxygen is taking place in this compound. Here Cu will get reduced and in the product we will get Cu only. And the oxygen which is lost by the Cu is gained by the hydrogen. So as addition of oxygen is taking place in the hydrogen, so hence here we can say oxidation of that particular hydrogen is taking place. That means if in a chemical reaction, both oxidation process is also happening and reduction process is also happening in a same reaction, that means a one compound and element lose electron, okay, or it gains oxygen and another element or compound doing this reverse process of it. That means both reduction and oxidation is happening in a same chemical reaction. Then we will say that it is a redox reaction. Understood? Understood, Aditya? Okay. Okay, anyone else? Yes. Tohit Kapoor? Okay, went out. Anyone? Anand?
Ma'am, show me that picture, ma'am.
Which one? Which picture?
मैम वो अभी था ना मैम पहले से
कौन सा वाला? Which one?
ये नहीं मैम वो क्वेश्चन मुझे समझना चाहिए
Question का?
हाँ यस मैम
Okay. This one you want?
यस मैम
Evaluation?
मैम व्हाट इज exothermic reaction मैम
Exothermic is this one. The left hand side, endothermic reaction, where release heat energy releases. Okay.
yes
Whenever
ma'am
any system is present and whenever the heat energy is releasing, that means it is an exothermic. Exo means exit and therm means heat. So here heat energy is released. Okay. Anything else?
yes ma'am
Any
yes
query? Okay. Move
thank
it.
you ma'am
Okay. Move it. Do you have any question?
Hello, ma'am, can we stop here? Hello. Priyanka, ma'am, can we stop here? Hello, Priyanka, ma'am.
Ma'am, I was having a doubt. I'm having a doubt.
Yeah, you are having a doubt, but Priyanka, ma'am, due to network issue, she left, I think. Just a second.
Teacher,
beta.
can I write the lesson in my notebook of science?
Yes, beta, you can.
Yes, teacher. That's why I was asking. Thank you, teacher.
Okay, students, due to network issue, ma'am has left, I think.